Okay, year 11. Just going to go through this work that you did for me last time. Well, many of you did for me last time. Still haven't seen it from a few of you, but anyway, so this is the feedback. Crude oil is a fossil fuel. Yes, it is. Millions of years old, dead sea creatures, plankton, etc. To make crude oil more useful, it is separated into fractions, fractional distillation. Use the correct word from the box to complete each sentence. Crude oil is a mixture. Trying to write it right, that one. Crude oil is a mixture of different substances. The substances in crude oil have different something points. Well, of course, it's boiling points. Remember that longer alkanes have stronger weak intermolecular forces between them, so longer, stronger forces. Crude oil is separated by fractional distillation. I don't think any of you will be getting any of those wrong. They were very straightforward. Petrol is one of the fractions produced from crude oil. Yes, it is. Car engines use a mixture of petrol and air. The diagram shows some of the gases produced. Now, I did a little bit about this today. You put petrol in, you burn petrol, you make carbon dioxide and water. What type of reaction happens in petrol in a car engine? Combustion. Okay. Petrol contains octane, C8H18. Complete the word equation. So we did this today. Octane plus oxygen makes carbon dioxide plus water. We'll be covering this in my next lesson. So you write down the symbol for oxygen, you write down the symbol for CO2, carbon dioxide, and you write down the symbol for H2O. You've got yourself 1 mark. So I keep banging the structure that this is stood on. What you would then do, and you'll see how to do this next time. So you've got 8 carbons here, so you're going to make 8 carbon dioxides. You've got 18 hydrogens, so you'll make 9 H2Os. And then 16 oxygens plus 9 is 25, so that's 12 and a half O2s. So you'll do that next time, but that's how you get your 3 marks, I imagine. 1 mark for reactants, 1 mark for product, 1 mark for balancing, maybe. I don't know, I haven't looked at the mark scheme. Next, some fractions on crude oil contain large hydrocarbon molecules. Remember, you can't sell your large ones. Nobody wants to buy the large ones because they're not particularly good fuels. Sorry, I keep saying nobody wants to buy them. Of course they do. People need diesel, but there is a greater supply than there is a demand. So you have some leftover large hydrocarbons. These molecules can be cracked to produce smaller, more useful molecules. An equation for cracking is this. Okay, decane, so this is propane and alkenes. Why is propane useful? Propane is going to be useful as a fuel. Small molecules are used as fuels. All straightforward so far, I hope. Alright, ethene. Ethene is an alkene. It's got a double bond in the middle. You need to know that for the 1 mark. What's the colour change when bromine water reacts with ethene? Orange to colourless. Straightforward learning that. So the bromine water test. Complete the sentence. Pentene is useful because many pentene molecules can join together to form. There's 2 answers you could have here. A polymer, or you can give it the name, which is polypentene. Either of those would be fine. You don't need to write both. Remember, from that, it's because alkenes make polymers. That's all you need to know. The diagram shows apparatus that can be used to carry out cracking reactions. So what you've got here then is a setup where you've got your long alkanes there. Oh, sorry. Here, sorry. There's your long alkanes that nobody wants. You're then going to heat them very strongly, and they pass over a hot catalyst. So they turn into a gas and they pass over a hot catalyst. This is where the cracking happens. And then the shorter alkanes are going to come through. Right. Why is aluminium oxide or broken porcelain used? That is the catalyst. We do this experiment in class. You still might get to do this experiment in class. Who knows? Paraffin contains decane. The cracking of decane can be represented by the equation below. A decane molecule is split into 2 smaller molecules. C10H22. Right, 2 of the carbons have ended over here. That means you've got 8 left. So I know I'm going to be dealing with C8. There were 22 hydrogens. 4 of them are here. So that leaves H 18. And you've got an alkane and an alkene, so you know that it's right. Next. Right. Would you expect C2H4 molecules to collect in position A or position B shown on the diagram? So what I would expect, it means it's tricky this. C2H4 is a small molecule which I would expect to be a gas at room temperature. So I would expect this gas to be bubbling here, this gas here to be C2H4. All of that gas will have been passed through now this is called a cold trap. What we're trying to catch here is the C8H18. If you make this test tube really, really cold, you might be able to turn the C8H18 into a liquid here. So that's the idea of this cold trap. I think this gas here is C2H4. Position B. C2H4 has got a very low boiling point. Therefore will collect as a gas. Cracking reactions involve thermal decomposition. Alright. Thermal means heat, decompose means break down. So thermal decomposition means to break down with heat. Break down with heat. Explain as fully as you can why cracking is used in the oil industry. Alright. To gain full marks in this question, you should write your ideas in good English, put them into a sensible order and use correct scientific words. Okay. There is a low demand and high supply for long alkanes. There is a high demand and low supply for short alkanes. Long alkanes are therefore cracked to form shorter, more useful alkanes and alkenes. I think that's fine. That's sort of the logic that I used in the lesson, and it's perfectly good. The cracking reaction produces a mixture of products. The mixture contains hydrocarbons with different boiling points. How might you separate the mixture? Oh, I don't know. Have we studied anything where you can separate things with different boiling points? Yes, we have. So a suitable method for separating anything with different boiling points is fractional distillation. I think you can get the mark for just saying distillation there. I think that's it. I'm just going to go back to this one. Explain as fully as you can why cracking is used. Now they do suggest in the mark scheme that you need to suggest why they've got a low demand. There's a low demand and a high supply for long alkanes because not a good fuel would do there, or they don't burn very well. There's a high demand and a low supply for short alkanes, e.g. petrol, because they do burn well. I think that's the only bit that you'd write. So basically something about why is there a low demand and a high supply, and why is there a high demand and a low supply. Done. Right, have a watch of that, see what you make of it, and I'll see you next lesson for some equation balancing.